How's it going? I'm eating a little bit of chicken, brown rice, and quinoa. You're ready to fail this class? What are you talking about? What in the world are you talking about? You guys having a good Monday? Good evening, Paul. Hi, Patrick. Welcome. How do I do this time-lapse thing again? You gotta get lapse it. Lapse it. We're vibing. We're vibing and eating some chicken with Cajun seasoning. Oh. Paul says, do I need to buy a phone holder or something? I don't think so. You can just like prop up your phone. Like, I didn't do anything special to record my video. I just balanced my phone against like this monitor on my desk. Or you could like squeeze it between two books. Something like that. That guy who stinks. Hey, how are you? Drewlish says, is there anything I need to do before lab tomorrow? I'm really confused. Are you an on-campus student now? Good evening. Good evening. If you're an on-campus student, there's really, excuse me, good grief. If you're an on-campus student, you'll be doing this workshop in lab. And I think it's a good idea to go through the lab manual before you show up to lab, just so you have some idea what's going on. And there's nothing preventing you from going through the workshop exercises at home in advance. Like if you have extra time that week. That way when you come into workshop, you'll already know what you're doing. You can quickly go through the exercises and have the TA check it off. 1985 says, found the old breadboard, let's do it. So this is only for online students, says Jab. Well, this is for anybody who is just more curious about Workshop One. I mean, this is particularly made for online students so that, like if you just want to have a more interactive time when you're going through Workshop One, this is a time you can do it at the same time as some other online students. I'm here if you have any specific questions. Calvin says, I got a problem with my breadboard. It's not it's not real bread, okay? It's just called a breadboard. Okay. You know, there's actually a history to breadboards, though. I need to go through the Wikipedia again. But I guess like they called it a breadboard because the original breadboards actually looked like a breadboard, and they were huge. They weren't, small like this. It did involve bread, believe it or not. Okay. Let's get started, everybody. I want to let's see. I want to do this. This is my first time going through a workshop like this, so you guys are guinea pigs. But I thought we'd start at the beginning, talk about the point, maybe go through some basics. And I want to do something like this every week. So this workshop is a little more straightforward, but maybe they'll get a little more complex. Maybe we'll have more we can talk about. But this one, it's basically an intro to Arduino. And the exercises in this workshop, you're going to be turning stuff on and off. Pretty basic. And we're just going to be turning on and off LEDs, which doesn't require very much power. So in a couple weeks, we're going to talk about relays. And you're going to use a relay when you want to turn something on or off that requires a lot of power. Or not a lot, but more power than the Arduino can actually produce. So a relay interfaces with an external power source, and it's a way of turning on and off bigger devices. But for now, just LEDs. The Arduino has enough power to turn them on and off. So we're doing that, and then we're also looking at how you do timing, how you separate events with specific amounts of time. So the most basic way to do that on Arduino is using the delay command. And when you use this, you basically say, hey, Arduino, wait 3 seconds, wait 1 second, and then do the next thing. But we're going to look at another way to do timing as well, which we'll get to a little bit later. So we'll be here for like the next hour. I think we'll kind of see how it goes. KT Feeney says, I'm having trouble in 1.4, exercise 1.4, delaying for half a second. Okay, we'll get to there. We'll get to that point. It'll be fantastic. All right, so if you're an online student, let me show you this table. Because this is going to tell you what you need to submit for your submission. So for every exercise, so there's 7 of them, there's some options of what you need to submit. So if we look at the first column, you're going to have to do a time-lapse video for exercise 1.1 as well as exercise 1.5. And all this time-lapse video does is it shows you physically putting the stuff together so that we know you assembled the circuit yourself. That's basically the purpose of it. And the software that we use, it's called Lapsit. Maybe I'll throw it in the chat. And you can just get this on your phone. If you haven't seen the example video I posted, you should check it out. Because I think if you watch that, it'll clear up what's required for the submission. I think that's the best thing to look at. So you have to do some time lapse. I suggest keeping, just propping your phone up against a book, prop it up against like the wall or something, maybe squeeze it between 2 books, but just keep it still while you do this time lapse. You don't want to be holding your phone in your hand and working with your other hand to build the circuit, because it'll look terrible when you replay the time lapse. You want your phone to be still. All right, so you also have to do some real-time videos. And this is once you finish the exercise and it's like, okay, my code is working, the circuit's doing what it's supposed to do. Then you whip out your phone, take a short video of the result, and explain, like narrate over the video. Be like, okay, here's what you're looking at. This is exercise 1.4. It's functioning correctly. And so on. And then you also need to grab a video of your computer screen showing your code. And you just quickly explain your code, explain what you changed, and so on. Drewlish says, is the lab manual on UB Learns? Yeah, it's on UB Learns. It's real easy to find. You go to course documents. There's a folder called workshops. You go in there and you pull up workshop 1. Easy peasy, lemon squeezy. All right, so those are the real-time videos. Thank you, that guy who stinks. And you also have to submit any code modifications. How can we find a lab partner? I sent a couple announcements about that. So check the announcements on UB Learns, check your email, there's a procedure. A lot of these things can be answered looking at your email. All right. Let's see. Maybe I won't spend way too much time here because I want to get more into the nuts and bolts of actually assembling some things. But if you want to, this first part's about what is a microcontroller. So this Arduino Uno is a microcontroller board. A microcontroller board contains a microcontroller on it. And so this chip right here on your Uno, this long one, this is the actual microcontroller. What's a microcontroller? It's basically a computer. You know, it has inputs and outputs. It can interface with different peripherals. But a microcontroller, what's different from the computers we're used to, like a laptop, a microcontroller typically just runs one process at a time. And so like when you look at the Arduino code that we're going to write, these codes typically just have a loop, one loop that runs over and over again, doing the same thing. So that's kind of what a microcontroller does. Okay, let's come back over here. Yeah, you can see, like I outlined in red, that's the actual microcontroller. And here's what the microcontroller code is going to look like, at least for an Arduino. And you need to download the Arduino IDE. Do you guys all have it? Do you have this software? If not, go get it. Okay. Maybe could somebody throw the link in there to the Arduino software just in case there's anybody who doesn't have it yet? Okay. So we're going to write some code in this environment. We're going to upload it to the microcontroller. Beautiful. Okay. Oh, right. You can't use... I won't let... I disabled links. Maybe I can get the link for you then. I'll throw it in the chat. Boom. Okay, so how about, because this next part of the workshop is about uploading a sketch to your microcontroller, how about we upload something to the microcontroller? If you go to UB Learns and you go to sample code, let's go over here. So I'm on UB Learns. Oops, went too far. Course documents, workshops, workshop number 1. Go to sample code and then get this one blinking LED. Download this. And then open this up, and it's going to look like this. Download that, open it up. Let's see here. And then what you're going to need to do, you're going to have to connect your Arduino to your computer via USB. So I got this USB cord right here. Boom. Phil, you sent me a link. Appreciate it. Thank you. Okay. So I got this hooked up. Let's go here. So if I want to upload this, I go to Tools. And then I go down to Board. And you're going to see a bunch of boards listed here. And the type of board that we have with the kit is the Arduino Uno. So you have to select that. Okay, so click that. And when you go to port, you should see your board, Arduino Uno, show up in one of the ports. Do you guys see that? I think sometimes when you plug in your Arduino for the first time, this might not show up for you. But like after you've connected your Arduino before, you should see it. Do you guys see this? Does anybody not see it? You guys saw it? Okay. Cool, 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 cool. It's going to be a nightmare putting all this stuff back in the box. Yeah, the struggle is real. I Love Salami says, I do not see it. Try maybe disconnecting and reconnecting your USB. And if you don't see your board after disconnecting and reconnecting a couple times, maybe try some of these random ones. Mine says COM3, is that okay? Okay, well, okay, even if you don't see it, for now, just select one. Oh, we actually need to connect it. Yeah, like at this point, you need your USB connected. Mine's plugged in. Wait, wrong one. So my USB is plugged in. When I go to Tools, when I go to Port, I have this option. Okay, it works. Beautiful. Okay, now what you should be able to do is click Upload. I mean, in the workshop, we tell you to click Verify and then Upload, but if you just click Upload, it has the Verify operation built into it. So the Upload button kind of does both. And if there's an error with your code, it'll catch it, and there's no problem. All right, so you should see something like this. It says done uploading, and it worked. Did it upload for everybody? No problem so far? If it uploaded, our next task is we're going to assemble this circuit, which corresponds to the code that we just uploaded. One blinking LED. So, okay, let's go and get the stuff out of our kit that we're gonna need to build this circuit. All right. So I have my kit. I've already opened it once, so now it's just a total mess. All right. If you're opening your kit for the first time, if you can keep it in pristine condition, I'm really impressed. All right, so you're gonna need your Arduino Uno. You're gonna need your breadboard. We're gonna need an LED. So I have these right here. I'm gonna get a red LED out. Now, the thing to notice about the LED is one leg is longer than the other. Maybe I can get this to focus here, I don't know. The longer leg is the positive, and it's important, the difference between these. If you switch the order, you could burn out your LED, okay? So we have to pay attention to which side is the positive. So let's just put that aside for right now. And we're going to need a 1 kilo ohm resistor. So in your kit, you should have a bag that has a bunch of resistors in it. And they're not all the same. Let's see here. Yeah, these are labeled. Like this one, it's 100K. I know I got this upside down, but that's 100 kilo ohms. This one is 1 mega ohm. I guess that's upside down. 1 mega ohm. So we're looking for the 1 kilo ohm. So it should just say 1K on it. Where are you? Just kind of... There's 2K. Wait, where's 1K? Oh, okay. It's like just the last one. It would always be that way. You can see these ones over here are a little bent because I've used these ones before and I put it back. Mounting the breadboard and an Arduino to a piece of wood makes it very convenient. Okay, nice tip. Okay, so I'm going to take one of these 1 kilo ohm resistors. All right, so we got an LED, we got a 1 kilo ohm resistor, and we're also going to need a couple wires. And if you look in your kit, there's going to be some that are shorter, some that are longer. We won't have to like cut these wires and stuff, right? Says Calvin. No, this is all plug and play. So we're going to grab some jumper wires, and you're going to want wires that have the male end on both ends. And I would pick there's longer ones and shorter ones, and I would just pick a couple short ones for right now. And I like to color coordinate. Usually red means power. Let's see. So I like to get a red wire. Well, mine are just all over the place. Okay, whatever. I'm just gonna grab that one, and a blue wire. Okay, we got a couple more. All right. And so our goal is to assemble this circuit right here. Let's see if I can maybe zoom in here. Let's try to get this to line up with the figure. I'm kind of doing this backwards, so it's a little tricky. Okay, the first thing I would do, let's place this LED in there into the breadboard, and I'm going to place the positive end, so the longer leg, up here on the very top row. So maybe if I get my hand out of the way, can I get even closer? The longer leg is plugging into the very top row, and the short leg, well, I just threw it, but the short leg I'm going to plug into like the third row. Boom. So it should kind of slide in there. If I pull it to the side, the longer leg is up here at the very top, and the shorter leg is like in that third row. Which resistance do we need? We need the 1 kilo ohm resistor. Now this part can be a little tricky because the resistors aren't always easy to plug in. So what I like to do first with the resistor is kind of fold it like this. Use a hammer, that's going to be overkill. I like to fold it like this. Kind of make a U shape. And now with a resistor, it doesn't matter which end you plug in. Like the LED, the polarity matters. For this, either way is fine. But what we're going to do on this third row where we had the shorter leg of the LED, we're going to plug in one end of the resistor. So I'm getting one leg in to the third row, and this is where I struggle. So if you're trying to put this in right now, it might give you it might not be going well for you. Okay, it went in. So that side on the third row went in. The other leg, I'm just gonna put it in the same column a couple rows down. And this is gonna take some work to get that leg in. But I think I did it. Is it going well for you guys? Are you struggling to get that resistor in? It's not always easy. If you keep it straight first and put one end fully in, then bend it, it works pretty well. Ooh, thank you, KT Feeney, for that tip. Are you posting these workshops on YouTube? Yep, we're gonna do that too. Okay, so just know if you're struggling a little bit getting the resistor in, it's not just you. Okay, it's kind of a struggle. All right, now from the Arduino, we are going to attach. Oh, I got the wrong wire. Let's first put one end of a wire, I'm choosing red, in the same row that we put the positive end of the LED. So it's up in the first row. Now remember, a breadboard, everything along a row, each row, those are all electrically connected together. So I have this red wire in the first row connected to the positive end of the LED, because the positive end of the LED is in that same row. And then the negative end of the LED is in the third row, which is connected to this end of the resistor because they're in the same row together. And so we're going to have electrical continuity going along that path. All right, now at this end of the resistor, whichever row you had that leg in, we need to put another wire. So we're going to have electrical current traveling, boom, along the resistor, and then back through this lower blue wire. Beautiful. Now this blue wire that came out of the one end of the resistor, that needs to go to a ground pin. There's a couple ground pins on the Arduino. I know it's kind of hard to see, but it's convenient. It's also written on the side here. That's the best way to see it, I think. If you're wondering, did I get it in the right pin? You can kind of just pull up the side and see, okay, I went to ground. All right, now the last step. Plug the wire that's going into the positive end of the LED into pin 13. Oh, I plugged it into pin 12, so that was the wrong one. You might be like, why isn't anything working? Check your pins. Ooh, and now you see. Something is happening. Is this happening for you? Are you having success? It's alive! It is alive. All right, let's, hopefully this is working for you. Let's go to our code a little bit and talk about, let's talk about our code. Okay, so we defined our LED pin to be pin 13. That's what we plugged into, right? And then if you go into the setup, so void setup, there's two main parts to an Arduino code. There's the setup, and then if you go later on, there's the loop. And those are the two main parts. But if we look at the setup, this is all like comments in here. It's not actual code. It's just telling you what's going on. We set that pin to output mode. All right. Can we change the title to Trial by Arduino? That's a really great idea. All right, and what this does is it sets that pin to output, I think it's something like 40 milliamps whenever we turn it on. 40 milliamps of current. So that pin is what's delivering the power to the LED. Type it says I'm unable to open the one blinking LED sketch on my IDE. Can't open sketch? Is anybody else getting that problem? Can't open sketch. Do you have this Arduino IDE? Like this software interface? Oh, sometimes if it's already downloaded, I can't open it from UB Learns. Well, what I would do is I would download it to your computer. I would save that sketch in a folder just on your local computer. Okay, great. Okay, so now we set the pin to output. Now we go to the loop. What's going on in here? So we use the digital write command to turn on this pin. So if you set it to high, that will make that particular pin output 5 volts. So 5 volts coming out of that pin when we turn it on. Now we use the delay command. This number in here is how long you want to delay. And the argument is in milliseconds. So if we put 1,000 milliseconds, that's 1 second. So this is saying turn on the LED, wait 1 second, and then this is saying turn off the LED, wait 1 more second. Ooh. Yeah, that's true. You can copy and paste the code from the workshop submission format page. That's true. You can open your Arduino, copy and paste the code in there. But sometimes when you copy and paste code, there's like hidden characters and you can get errors. It's weird. It's best if you can just directly open the code. Okay, but that's all that's going on in this loop. Turn it on, wait, turn it off, wait. And then the loop just repeats over and over and over again. And that's why we see it just keeps going. So that is exercise 1.1. Just getting that to work. Now, if you're an online student, I don't know if you're doing this right now, but you should take a time-lapse video using Lapsit, a time-lapse video of yourself building this circuit just like we did. And that's all you need for this exercise. All right, let's go on to the next one. I won't give this away, but I think you're going to figure it out really quickly. Modifications. Modify the sketch so that the LED is on for 3 seconds and off for 1 second. So if you go back to the code, what does it do right now? It turns the light on, and then it waits 1 second, and then it turns it off, and then it waits another second. So you want to modify this code so that it stays on for 3 seconds. So as you can tell, you're going to be changing one or possibly both of these delay commands. So play with it, figure it out. Once you figure it out, you're going to see a change in the result. And you need to take a quick real-time video demonstrating that you have successfully achieved that trial by Arduino. All right. So that one's not so bad. Okay, this is an interesting one. What does the red button on the circuit board do? That just resets the Arduino. So like if I go here, like you can press it. So I'm pressing, we're talking about this red button right here. It just starts over the code. So sometimes you might want to reset something. I think it just runs the setup section again, then goes right back into the loop. All right. So exercise 1.3 is opening up the one blinking LED no delay code. So that's also found in the sample code on UB Learns. Let me open that up. So I think I just have it on my computer. Okay. This code does the same thing as the previous code. It turns the light on and off for 1 second at a time, but it does it in a different way. The delay command, there's a problem with it, depending on your application. Delay pauses your whole code. Like while this pause is happening, nothing else can happen in the background. It's just like a dead zone in your code. But sometimes, like while you're turning the light on or off, you might want to be doing some other tasks in parallel. Maybe you're reading data from a sensor. Maybe you're making a motor spin and do some task. So we need a way of regulating timing without stopping the whole code. So that's what this is about. No delay, meaning it's not using the delay function in order to achieve timing. So let's talk about this. Let me explain it. First, I think this is the most important variable here. Interval. We just made up a name. That's not special, but this is saying how much time we want to wait in between turning the light on and off. So it's in milliseconds. It's 1 second right now. Let's go into the code really quick. This might be the easiest way to describe it. All right, let's pull this. Okay, so let's talk about the loop. The first thing that we do when we go into the loop is we use this millis command. What millis does is it tells you how much time has passed since you started this Arduino sketch. So when we upload it, it starts running. Maybe the first time that the code starts and we get into this loop, the code's been running for 1 millisecond or something. So when we first enter this loop, it'll say current millis equals 1 or something like that. Okay? The next thing that we do is we have this if statement. It says if current millis minus previous millis is greater than interval, and remember we defined interval to be 1,000 milliseconds. So if this time difference is bigger than the interval that we want to wait, then we go into then this if statement evaluates to true, and we're going to do what's in here. Okay. So what is previous millis? If you go back to the beginning, we just set it to 0 at the very beginning of the code. So just keep that in mind. So when we first go into this loop, maybe current millis is 1 millisecond. We've been running for 1 millisecond. Well, I take 1 millisecond minus 0. Is this greater than 1,000? No. So this code's just going to keep running. By the way, if the if statement isn't satisfied, we just skip it. So all this code that happens in between these brackets, from here to here, we're not going to run any of this unless the statement is true. That's how an if statement works. Okay, so until this time difference becomes greater than 1,000, we don't run this. But once it is greater than 1,000, what do? We update previous millis. So maybe it's after 1,001 milliseconds that this if statement finally becomes true. Well, the first thing we do is we say, okay, well now previous millis is going to be 1,001. So that when we start counting again, this if statement, it won't be true again until this becomes 2002 or something like that. All right. And okay, what do? This is saying if the light is off, turn it on. Otherwise, if the light, what's implied here is otherwise, if the light was on, then let's turn it off. So basically this set of code just changes the state of the light. And we don't actually turn on or off the light until we run this digital write command, because this is what actually tells the pen to do something. So in this case, we just made a placeholder variable, LED state, and we can just change it to high or low. And then we write this. I Love Salami says, I keep getting this error, can't set com state for COM3. I would maybe check, like I would go to tools and port and make sure that it's set to your Arduino Uno. Like that looks like it might not be at the right port or something. Because it worked for your previous code, right? So I would probably just change that port. Okay. All right, so let's upload this to the board now. So you go to tools, make sure that all of this information is correct, and we're going to try uploading it. And if it uploads correctly, down at the bottom it'll say done uploading and so on. And so this new code is on the board, and you can see in the top right of the screen that LED is blinking on and off at 1 second intervals. So it's doing what it's supposed to do. So exercise 1.4, this might be the first tricky exercise of the workshop. Because what you need to do is modify the sketch so that the LED is on for 2 seconds and off for half a second. So it's kind of this uneven interval. It's not just on for 1, off for 1, it's on for 2, off for half. And this is really a coding exercise. And I'm not going to give you the solution because I think it's really satisfying to think this through and come up with a solution. There's not only one way to do this, there's a couple ways. But I'm going to give you a hint. I'm going to give you I'm going to let you know that some things are possible, and that might lead you to a couple different ideas. This coding is better than MATLAB, says Phil. I'm glad you enjoy it. I mean, this coding is, I don't know. It's different. It's cool that it results in something concrete in front of you that you can see. I assume using delay is illegal. Yes. It doesn't explicitly say don't use delay, but you can't use delay. The goal is to not use the delay function. Oh, wrong code. Okay, so I said I was going to give some hints. Interval. We define it to be 1000 up here. But within your loop, you could add a line in here where you change what the interval is. If and else if are hints. Yeah, you're still going to have to use if statements. You're still going to have to use this kind of logic of checking if a difference is greater than an interval. But so my first hint is within your loop, you can update what interval is equal to. You don't have to only have it equal to 1000 up here. Within this actual code, you could say interval is equal to something else. And so as the loop progresses, it could always be updating what interval is. All right, so that's hint number 1. Another approach is you could define a second interval. Like you could have 2 interval variables. One interval is equal to one thing. Like you could call it interval 1. And then maybe you could define interval 2 and it's equal to something else. And you could have more than one if statement in your solution. That's certainly possible. Okay, so those are the hints I'll give you. I gave you like 3 pieces of information. You can come back to this video, maybe think about those possibilities. And I know you guys already have your own ways of doing this, and maybe it doesn't involve anything I mentioned. There's many different ways. Okay, let's go back here. So this is your first kind of tricky thing. All right, so next is exercise 1.5, and all this is you're adding another LED. How about we do that? We're all here hanging out. Let's add another one. For now, I'm going to unplug my Arduino. I'm gonna pick a green LED. I guess you don't have to pick green. There's a bunch of different colors in here. And basically, you want to just replicate this circuit we have at the top, but with another LED. So I'm going to kind of randomly plop this green LED down, further down. And I'm going to do like the same strategy where the longer leg, I'm going to place at the top. And I'm going to stick it, I'm going to put it in the middle column here. All right. And then that guy who stinks, I appreciate you helping with that debugging issue. That's really nice of you. Okay. Now we need another 1 kilo ohm resistor. Is this the one? No, it's 2. Okay, so I got my 1 kilo ohm. I got these bent wires. Are the terminals on your breadboard tight? Yeah, mine. Sometimes I have trouble inserting these wires. Actually, I'm going to use the tip that somebody gave earlier. I forget who it was, but they said it's easier to start with the resistor straight. So let's just do that. And I'm going to plug in one side on the negative end of the green LED. Focus. So on the lower end, I'm just going to... Okay, this is kind of bending on me. Probably because I already bent this. Okay, but it went in. It went in. So you can see I got that one side in there. And okay, now I'm just gonna plug in this other end somewhere further down. Same column. Even though I guess it doesn't have to be in the same column. And this is always the more challenging to get in there. Okay, I think it went in. Yeah, the resistors are not super easy to get in there. Okay, so we need 2 more wires. I'm going to take the negative end. Ooh, actually. So we have a little update here. If you look at the schematic, maybe I'll pull that up. Wrong one. Here, I'm taking the ground from the Arduino and I'm connecting it into this negative rail, this column. And on the breadboard, these outside columns are connected all the way down the length of the breadboard. So if I connect anything in this column, it'll be connected to the ground. So breadboard gives you effectively more pins to use, because we can't just be plugging like everything into a different ground pin on the Arduino itself. We need these things to share ground. That guy who stinks says, I found if you prime the breadboard inserts with the male end of the female to male wires, things are often easier to insert. Okay, thanks for that tip. I think I've tried that before too. Like if you could take some, like these jumper wires are a little more, like these ones are a little more stable. So you can take this end and maybe before you try to plug in a resistor to a hole, first plug this in and it'll kind of make some space. Thank you for that tip. Okay, so we're gonna take this negative end and we're just gonna plug it into the negative rail. And I'm gonna do the same thing with that resistor up there. And then we're gonna go from the ground of the Arduino. Yeah, I got that into the ground. I'm gonna take that and plug it somewhere also onto that column. So you can see all 3 of those are in the ground column. All right. Now let's see. The pin that we're going to use to connect to the positive end of this green LED, I think we're going to use pin 10 on the Arduino. So I got to find another wire. Ooh, orange. Let's use that. Okay, so I'm going from 10. Plug that in there. And then this is going to go to the positive end of that green LED. So we just replicated that LED circuit up above, and we also kind of changed where the ground pins go. All right, so now I'm going to plug back in my Arduino, and we should only see the red pin going on and off right now because we still have the old code uploaded on there. If you unplug and replug in your Arduino, the Arduino remembers the last sketch that was uploaded to it. So it's running the previous sketch. All right, but we want to upload the 2 blinking LED sample code. So I'm going to open that up. This is a real simple code. This time we define the red pin, the green pin. We define them both as outputs. And then in the loop, this code is actually using the delay command, right? So I'm going to turn on both of those lights, wait for 1 second, turn them both off, and then wait, and then just repeat over and over and over again. So let's upload this We go to tools. We go down to the board. We make sure it says Arduino Uno. We go to that port. As long as that all matches, we're good. And then we're going to upload it. And okay, no problems. Now we see both lights going on and off. Waiting 1 second, going on and off. Is this working for you guys? Are you keeping up? Am I going too fast? I guess you can always come back to this later too. It's all good? Okay. What if we're not sure if the light is waiting 1 second or half a second? Something you could do, get out the timer on your phone. Let's see. Where's this? Wait, you want to do the stopwatch. Can I get this all in here? I just got to flip this around. Wait, what happened to this light? Did I unplug something? Wait, what did I do? No, this was plugged in the right order. Did this get disconnected? What happened? I might have killed it. I don't know what I... Wait, did I upload? Okay, I'm gonna upload this code again. Wait, what did I... What did I do? I think my resistor's in okay. Ground. Wait, what? Now it just started. Yeah, I'm in pin. Okay, maybe. Oh, dude, it's this wire. It's this orange wire. I can feel it's like a little bit loose. All right, let's try a different wire. You might run into some duds in there. I think that's the first bad wire I've run into, but it could happen. Okay, let's do pin 10 again. Going to the positive side. Okay, now we're all good again. Oh yeah, but what I was saying is this will give you like a rough idea. Okay. Okay, so the next exercise. Modify the sketch so the green LED is lit while the red LED is off, vice versa. That one, I think you're going to figure it out very quick. This one, modifications, same circuit. You're going to have to use some of the skills that you gained from exercise 1.4. If you can do exercise 1.4, I think you'll be able to do this. Remember the tips I gave earlier, like redefining the interval command, defining multiple interval commands, making multiple if statements. Do we need a stopwatch for those? No, Calvin. I think it'll suffice. I think it'll be clear from the video if it's working or not. It's not necessary that you have a stopwatch next to it. Even though, now that I think about it, that's a pretty nice idea. but I don't think it's necessary. Wow. So it's exactly 8 p.m. I think we've gone through the essentials of this. So I'll hang around for a couple minutes. If you guys have questions, I suggest going through this workshop, the text in more detail. This goes into more detail, gives some more like example, like if you're stuck on 1.4, this gives a little bit more explanation on how those codes are made. But that's the gist of it, my friends. What questions do you have? You feeling good? Okay. Thanks, bye. Hey, you're welcome. Did everything end up working for you? Did things get debugged, Salami? I know there were some issues earlier. I think it's a problem with the port on my computer. So it's still not working for you? You have to keep unplugging, basically. Do you have multiple USB ports that you can try? I might try different USB ports. Sometimes a port just isn't going to work with you. I've encountered that sometimes with the computers we have in Furnace 810. Just like inexplicably, one USB port will work and another won't. So yeah, try a couple. Is anybody else having technical issues, or is it going pretty well? Hey, you're welcome. Let us know if you have problems. Go to the Discord. The Discord has proven to be very, very helpful. Lots of very helpful people. All right. Guys, this has been fun. I hope you enjoyed it. We'll do something like this each week. Have a good night. Hang in there. Hey, you're very welcome. I'm glad you liked it. Give me feedback on if there's any way I can make this more helpful for you. You guys are welcome. All right, see you guys soon. Have a good night.